Hello, I'm Ushin Shim from the CVPM lab, and I will be conducting this review. The title of the paper I will be presenting this week is Enhancing Stability and Reliability in LLM-Driven Robotic Manipulation through Human Scale Demonstration and Visual Tracking. The presentation will proceed in the following order: abstract, paper structure, limitations of existing research, conclusion, key elements of this study, and paper summary. In the abstract, I will discuss the context, the unique approach of this study, the research, and the framework in that order. In the abstract, I consider the context to be LLM-driven robotic systems. The unique approach of this study lies in its ability to perform self-collection of action using LLMs and cameras, as well as learning from human behavioral patterns. The research results demonstrate an improvement in decision accuracy. To wrap up, the context of this study is LLM-driven robotic systems. The unique approach of this paper lies in training through LLMs and using cameras for autonomous error correction, while learning from human behavioral of ultimately improve the accuracy of robotic movement. The framework of this paper consists of LLMs, human demonstration, and visual tracking feedback control. Regarding the structure of this paper, I will go over the title, the researchers, and the table of contents. Regarding the structure of this paper, the title is Enhancing Stability and Reliability in LLM-Driven Robotic Manipulation through human skill demonstration and visual tracking, and it was authored by four researchers: Yi Guo, Hao Chu, Xin Guang Wen, and Fei Wang. This is a list of papers being reviewed today. Now, I will discuss the limitations of existing research. Previous studies suffered from a lack of robot integration with LLMs, resulting in a weak connection between high-level planning and actual robot control. Furthermore, they were less adaptive to environmental changes, making them vulnerable to shift in object positioning and show deficiencies in learning from human skills. Finally, the inability to provide real-time feedback and the lack of visual tracking-based calibration remain significant challenges. In conclusion, I will discuss the significance and implications of this study. The paper concluded that integrating structured prompting, state management, and safety validation significantly improved the stability, security, and reliability of LLM-driven robotic systems, with substantial performance gains demonstrated in both simulated and real-world experiments. I will now discuss the key elements of this research. I think combining LLM's listening abilities, human-derived manipulation skills, and visual-based real-time feedback can lead to the creation of intelligent and reliable robotic manipulation systems. Chapter 6 Summary of Research. Hello, my name is Ushin Shim from the CBPM lab. For my doctoral studies, I am interested in physical AI for construction sites, so I selected this paper for my first review. Existing robot systems, even when using large language models, are generally limited to simple tasks and often struggle with complex sequential actions in dynamic environments, which make their application in real construction sites difficult. To address this limitation, this paper proposed an autonomous operation framework that integrated LLM-based reasoning with robotic physical control. The framework of the paper is the integration of three main components. First, LLM-based reasoning, which allows the robot to perform tasks through step-by-step logical decision-making. Second, running from the motion data of skilled construction workers, enabling the transfer of human skills to robotic systems. Third, camera-based visual feedback, which allows the robot to observe the environment and collect each action in real time. I believe that the integration of these three elements represent the unique methodological contribution of this paper. Furthermore, this approach suggests an important direction for physical AI research that aims to transfer scarce human expertise to robots in construction environment. Thank you. Thank you for your attention.